Okay, so we finished the textbook chapters. The last thing we talked about was Louisiana's natural resources, what you can do to make a better environment for us to live in. We talked about the watershed, what conservation is, saving our resources, all of these things. And I think it's a perfect transition into talking about coastal science and our coastal oceans. So I'm going to be giving you the lecture that I gave 7th grade earlier in the year. I'm going to break it up into a bunch of parts so it's not too overwhelming. And if we end up getting through this, then I will see about making that unit on natural disasters that we talked about. So that should be pretty cool. Let's see how far we get with this, though. Okay, so go ahead and get this started. There we go. Okay, so this is actually a picture, this background right here. I'm pretty sure you can see my mouse. This picture is of Louisiana salt marsh. It makes up a lot of our coastal regions. Anytime you get closer towards the ocean, the salinity or the amount of salt and particles, dissolved salt particles that are in the water, it increases. And you get all the way up to 35 parts per thousand. That means for 1,000 parts, 35 of them is salt. And salt is not just sodium, it's a bunch of different elements that are in the water. But the closer you get to the ocean, the increase in salinity. Okay, and when you increase salinity, you end up getting very few different species of plants specifically that can tolerate that amount of salt. So when you get to coastal regions really close to the ocean, you tend to see pretty much the same thing no matter where you look. If any of you have gone fishing with family members or by yourself, and you've gone saltwater fishing for redfish, trout, whatever it happens to be, if you sometimes, especially in places like Cocodrie, I'm not talking about South Plaquemines. Venice has a lot of fresh water from the Mississippi River. If you go to places like Cocodrie, Lower Barataria, even in the southwest of the state near Lake Charles, you look around and everything looks very similar. And that's because these plants, not a lot of plants, can tolerate that immense amount of salt that comes from the ocean. But you're not going to have to know this, but you have four major species of plants. We have cord grasses, which are Spartina alterniflora, Spartina patens, our two main cord grasses. We've got Juncus romerianus, which you can see a little patch of it right here. Those are the long tube-like pokey grasses that you find if you ever walk out there. They have really sharp tips and they'll poke you. And we have something called Disticulus spicata, which looks almost like the lawn. That's the lawn that's kind of out near the edge right here. It kind of lays flat. But our tall grass that we see all throughout here is all called Spartina alterniflora. And it's one of the most common salt grasses you'll find in the Gulf Coast all the way up to New England. And then also you find, especially in Louisiana and in Florida, you see mangroves. And we'll talk about mangroves maybe towards the end. But the mangroves we have here are called black mangroves. They can tolerate some freezes, which Louisiana does have some freezes. So we have black mangroves here. And when you travel over to Florida, you get some other types of mangroves, the ones that you see in things like, if any of you watched Octonauts when you were little, when they went through the mangrove forest, and they had these huge roots that came out from underneath the water, and you could see their roots above the water. It's this huge matrix of roots that are in the mangroves. That's a different type of mangrove. We don't have those here because any kind of freezes kills those off. So, yeah, as you know, this is my background. This is my expertise. This is me on the right doing some sampling. I took the picture in the center. This is all Spartina alterniflora, this tall, beautiful green grass that's in the middle of summer, peak growing season, where it has a lot of nutrients, there's a lot of sun, it's really warm, these plants can really thrive and grow. And on the left, we have more fresh water than salt water, but you can see bottom left in this picture, that's some of the black mangrove which has become really highly populated and very dense in southern Louisiana. All the background, that dark green, that's all black mangrove. And we recently had a die off of a lot of our black mangrove because a couple of years ago we had some really intense hard freezes. And we had a lot of them that lasted for a decent period of time. And the more freezes you have, the worse off the black mangroves are. Alright, so let's talk about what are coasts. Well, coasts are areas where the terrestrial biomes transition to oceanic biomes. Now, we didn't talk about biomes this year because that's more of a 7th grade subject, but biomes are these zones in the world that we live in that are defined by their temperature and their location, their rain, things like that. So we have desert biomes, dry deserts, like in the southwest of the United States. We have coastal biomes. We have Arctic biomes. We have boreal forests. We have all these different biomes. You can look up the definition of biome, and there'll be a ton of examples out there for you. And we have ocean biomes. We have all these different biomes. And it's just saying that this environment that these organisms live in have these common factors. So a terrestrial biome is just a biome that's on land, and an oceanic biome or aquatic biome is a biome that's in the water. So coasts are a transition area. It's where we're going from land to water. That's our coast. The coast is not a line that outlines a piece of land. It's a large area, and it's a transition from our land into our ocean. Now, our coasts are dynamic, which means they are constantly changing. That's a big thing I want you to remember is coasts are constantly changing. They don't stay the same. Our coasts are dynamic. That's what that means. So our coasts, dynamic, constantly changing, and they are not a line. They're a large area. So they're shaped by a couple of processes. They're shaped by terrestrial or land processes, and they're shaped by aquatic processes. So some of the terrestrial processes we could talk about, wind, earthquakes, things like that, things that aren't originating from the water. And then aquatic processes are things like tidal movements, where the water is moved up on land from lunar or moon cycles. The gravity from the moon, we learned about the gravitational pull of the moon and how it's influenced on Earth. And I believe we talked about how one of the main things that the moon affects is our tides, and how the moon moves, gets closer to Earth, different cycles. It pulls the water, it pulls on that water, and it creates what's called high tides, and that's when the water moves into our land. And then when we have less pull from the gravitational pull of the moon, we have what's called a low tide, where the water moves away from the land. So tides shape our coast because of erosion. They go up onto the land, and when they recede, when the water goes back out into the ocean, it pulls sediment with it. And as that sediment moves away, we have less sediment or soil. Sediment is a term for soil that's deposited by water. As that water moves away from the land, it pulls sediment with it, and it causes erosion. Now on the other side, if we have a lot of sediment suspended in the water, when we have a high tide, some of that sediment gets deposited back. And that's one of the things we might talk about is diversions, and why they are such a hot topic nowadays, and why so many people are discussing them. So I think we'll talk about that at the end, though. Now, we talked about how coasts are not a line, but a shore is a line. The shore, you can think of it as the shoreline. The shoreline is that singular line where the ocean meets the land. And where our coasts are larger zones that are affected by the processes that occur at the shore. So we have processes, these different things, this tidal movement and things like that that occur at the coast, at the shoreline. And as far in as that reaches, that's our coast. Now we're talking about ocean. When we define ocean, I'm not saying oceans. I'm not saying multiple oceans. I'm saying ocean, singular. There's one world ocean. There are not multiple oceans because they're all connected, right? Now, the different names like the Atlantic, Pacific, Indian, all these different names for ocean were given by people to help segment the ocean into more navigable terrain, more navigable waterways, so we could understand where we were and communicate where we were. But in reality, there's only one world ocean. So I'm not going to refer to specific oceans, but one world ocean. And little fun fact, if any of you have heard of Pangea, back when the Earth, millions of years ago, all the continents were together in one continent, it was called Pangea, right? Well, the ocean had its own name too, and it was called Penthalassa. Penthalassa. So that's pretty cool. Not a lot of people know that, so that's a fun fact you can have in your brain. So it has vast expanses and depths, and it makes it difficult to explore. The ocean is huge. It's way more space to cover than it is for land. There's a reason we've covered and discovered most of the land on Earth. There's a reason that we haven't discovered everything we know about the ocean. It's extremely deep. The deepest parts of the ocean, these trenches in the ocean, some of them are so deep that you can fit Mount Everest in it multiple times. So it's difficult to explore not only because it's so huge and it's so deep, but it's so expensive. And when we do get one of these pieces of expensive equipment that allow us to dive to the deepest parts of the ocean, we basically get a little small column of the ocean discovered. We don't get to discover everything around it because it's very difficult to see. Light doesn't penetrate down to the bottom of the ocean. So it's home to some of the deepest valleys and the tallest mountains on Earth. So we look at this. This is part of the world ocean that we call the Atlantic. And in the Atlantic, we have the Mid-Atlantic Ridge. And ridges are formed by tectonic plates and when tectonic plates move. I'm sure you've all learned about tectonic plates. If not, tectonic plates are these plates of solid rock that are just above the upper mantle, and they float. They're part of the crust of the Earth, and they float and move slightly. And here we have where two plates are butted up against each other, and they're moving apart. And as they move apart, these volcanic ridges create new land, and it's some of the tallest mountain ranges in the world. We just don't see them. That is a perfect example of a ridge. So we look at our coastal oceans. We have this whole ocean out here with many different features. But when we look at a coastal ocean, it has different things that it's broken down into. We have our littoral system, or our near coast system. We have supratidal. Supra means above or high or upper. Supra, above the tide, right? So if we combine these, supra, upper or above, tidal, dealing with tides, this is above the tidal range of the ocean. So everything that's occurring above the tides. And then we have the neritic system. It's everything that's occurring below the tidal range. And our neritic system has our intertidal, meaning our tides where it's moving in and out, intertidal. It's both supratidal and over here in the littoral system, the neritic system. Our littoral system deals more with this benthic realm, benthic meaning below. This is our dirt realm, our substrate. We have subtidal. This is our realm that's below intertidal. It's below the tidal, intertidal. Then we have bathyal, abyssal, and hadal. And then they're further broken down into two main areas. We have the photic zone. The photic zone, photic meaning light. So photic zone is our light zone. Most of our neritic and littoral system is within the photic zone, so it's broken down over here in the ocean system, because as we get past the photic zone, which goes to 200 meters at most, the photic zone is where light can penetrate down. And then once we get past the photic zone into the bathyal, abyssal, and hadal, we're in the aphotic zone. A meaning no or absence of light. Absence. A for absence of light. So we have the photic zone where light penetrates the ocean, and then we have the aphotic zone where there's no light. And that can range anywhere from 200 meters to greater than 6,000 multiple kilometers. It's multiple kilometers deep. So let's talk about tides for a second. And tides are periodic, short-term changes in height of the ocean surface at a particular place. The main causes of gravitational force, main causes of tides are the gravitational force of the moon. We talked about that. The sun has a gravitational pull on the earth, and it affects mainly the earth, less so the tides, but it does have an effect on our tides. Not as much as the moon, but it still does. And the motion of the earth. So the spinning of the earth and the changing of the earth compared to the sun all has influences on how our tides move, how that water moves in and out of our estuaries or our coasts. I'll define estuary later. Now, periodic means it's appearing or occurring at intervals, meaning it doesn't constantly occur. We're not constantly at high tide, we're not constantly at low tide. It's saying that we have intervals, means it happens here and it'll come back. So we'll say we go to a high tide, down to a low tide. It happens at intervals. And we can plan these intervals. We know when they're going to happen. So these are short-term changes. They don't stick around. They're not super long. They're short-term changes in height of the ocean surface. Now, compared to a lot of places, Louisiana has a very long tide. It stays high tide for a while and it goes to low tide for a while. Some places it happens within hours or even minutes. And in some places in the Northeast and up into Canada, there's some crazy tides that occur where it's multiple meters deep and it happens very quickly, maybe 30 minutes. Whereas in Louisiana, we have maybe a meter tide difference where the water gets maybe a meter higher at most. And just think of a meter stick when you're thinking of a meter. At most, it gets about a meter higher than usual, and it occurs over the period of 3 to 6 hours. It takes a while. So here's one of the tidal ranges we wanted to talk about. This is the Bay of Fundy. Now, the Bay of Fundy is in Nova Scotia and New Brunswick. It's this little channel that separates New Brunswick and Nova Scotia in Canada. And just for reference, that's just to the northeast of Maine, right off of Maine. So within 23 minutes, they have a 3.3 feet rise in water. 3.3 feet of water change in 23 minutes. See these people walking around. You can see that how high it is. This is actually higher than 3.3 feet. If you think about it, we'll look right here. This person is not 2 feet tall. So in this particular point, there's probably an 8 to 10 foot change. We'll say 8-foot change in water. See how high this person is right here? It's about 8 feet in 23 minutes. Very dangerous. High currents and sometimes very unpredictable. Not someplace you want to be. So, but we don't have these kinds of tidal changes where we live. We have what's called we have kind of a mix between diurnal and semi-diurnal. So semi-diurnal is where we have it occur twice in a lunar day, where we have a low tide, a high tide, a low tide, and another high tide in a single lunar day. Diurnal is where we just have one low and one high tide. And mixed tides, we'll have something like a low tide, a high tide, a lower tide, and a much higher tide. And it's very different tidal heights. It's not the same amount of movement every time. So Louisiana does not have mixed tides. I believe we have mainly diurnal, where we have one low and one high. Now the location and shape of coast. These are due to things like uplift and subsidence. Uplift is the upward movement or the upward change in elevation in land, something that causes land to move up due to geology, not due to depositing sediment. It is uplift. It is being pushed upward, not deposited and growing land, but pushing it up. And subsidence is the geological change where it moves downward in elevation. It's a sinking of the land. If you think about it, what do you think Louisiana has? More uplift or more subsidence? I would say more subsidence, because all you hear about is Louisiana's sinking problem, right? We don't have a whole lot of uplift occurring because we're not really on large geological faults. We're not having a lot of uplift and earthquakes and changing of our land upward. It's mostly due to subsidence as our land change. We have erosion taking place. We talked about movement of water onto and off of the land, either from tides or rain or storms, and pulling sediment away. And from man-made canals cut through our marshes that are making water move faster and it's pulling sediment away. And redistribution of sediment by transport and deposition. So that's one of the ways it can change the coast, is by this sediment being picked up, transported or moved, and redeposited. So it's redistributing the sediment. So the sediment is being picked up, moved, and deposited somewhere else. So we might have like some erosion over here, but down the way, down the coast, we might have an island being built. All right, so sea level and coastal change. There's 3 eustatic changes, and eustatic means worldwide changes. It's going to be pretty easy to understand the difference between eustatic and the other type of change. Once I get to it, you'll see what I'm talking about. But there are 3 eustatic or worldwide changes that occur. We have the amount of water in the ocean can change. How do you change the amount of water in the ocean? You put more water in it, right? Well, how do you do that? One of the ways that more water is added to the ocean is through the warming of the environment, right? We have an increased amount of warming. It can cause the ice caps to start melting, and if that occurs, I'm not here to argue this with you. This is one of the ways it can happen. If these ice caps melt, we have an increased amount of water in the ocean, and that's just a fact. That if ice caps melt, we have more water in the ocean. It's not the first time it's happened. It's cyclical, meaning it happens in cycles. It'll happen down the road, and we'll end up having another ice age too. But if the water increases in the world ocean, we have a worldwide change in sea level. The volume of the ocean container might vary. So the ocean as a container, the shape of the ocean. Let's say we have more ocean floor now. We have a larger container. Say we have more valleys get ripped open in the bottom of the floor. We have a larger container. It's deeper now. So if we have something like that happen, water goes in and fills it, and it lowers the sea level. Water might occupy more space. How does water occupy more space? Well, as we learned in our temperature unit, as we heat up an object, the atoms move apart. They space out. So if we heat up we talked about entropy and heat, and they said water doesn't follow the same rules. It doesn't expand. This is what I was talking about. Water does expand when it is heated up until it starts boiling. Water molecules will space out, and as they space out, they occupy more space. You heat up that water, it occupies more space, and if it's occupying more space, it has nowhere to go but up, and it'll rise. It'll make that sea level rise. Now, the other type of sea level change is called local change. So eustatic, worldwide, local. If you can remember local, you know that the other one means worldwide. Local means it happens in a specific area, one small area. It's not worldwide. This happens a lot because of tectonic movement, where we have uplift from lifting plates, or maybe a heavy glacier is pushing down on a continent, and it changes the sea level in that specific area. So it's relative, or it's highly dependent. It relies on changes in land. So we have uplift occurs in one area. It's a local change. It's not affecting the water level or the ocean's level worldwide. It's just saying that, relative to the sea level, we're a lot higher now. That's the kind of change you're talking about. And we also have things like winds, current, storm surges, and all kinds of other things. So Louisiana has their tidal changes are highly dependent on wind. So if we have a strong wind coming out of the south, it's going to push more water up, and we have a relatively higher sea level because of it. We have a lot of wind pushing water up. Everything's flooded. It appears that our sea level's higher. Storm surges. So when we have a storm surge move in, storm surge from a storm, from hurricanes, is a big, basically, wave of water that's being pulled up from this storm. I'm not going to talk about the differences in pressure and all that, but we have a large wave coming in, and when that large wave comes in, it gives us a relatively higher sea level for a period of time, and it's local. It's not happening all over the world. And that's where I'm going to stop for part 1. I'll upload part 2 later in the week. In the meantime, go ahead and answer the questions, which are mostly definitions, in on your Google form that I've attached to this. Hope you enjoyed.